Question number 1, part A. A block is cut into equal units of 10 grams, 20 grams, and 35 grams. Use prime factorization method to find the smallest possible mass of the block for which the pieces can be cut. Okay, so this is the LCM problem. So let us have the prime factors for each number as follows. The prime factor for 10 are 2 times 5. For 20 are 2 times 2 times 5. And for 35 are 5 times 7. Okay, so next, to find the LCM, we are going to take all appeared factors for each number. Then we are going to have 2 times 2 times 5 times 7, of which after solving the value, we are having 140. Therefore, the smallest possible mass of the block for which the pieces can be cut equals to 140. That is going to be our answer. Question number 2, part A. Find out which of the two fractions, 5/7 or 6/9, is greater. Okay, so for this one, in order to find which one is the greater than the other, let us convert the numbers into percentage. So we are going to multiply each number by 100. So we are starting with this one, 5/7 times 100, of which, solving this, we are getting 500/7. After dividing this, we are having 71.4%. Okay, so next, we are taking this 6/9 times 100, of which this becomes 600/9. Okay, so solving this, we are having 66.7%. So now we can see that 5/7 has a greater percentage, and this is going to be our answer. Part B of the question, if 0.125 of all students in a mixed class are girls, what percentage of students are boys? Okay, so for this one, after being given this decimal, in order to find the number of boys, we are going to take 1 minus 0.125, which after solving this, we are having 0.875 of all students. Okay, so now to find the percentage of boys, we are going to multiply this decimal by 100. Then we are going to take 0.875 times 100, of which after solving the values, we are having 87.5%. And this is going to be our answer. Question number 3, part A. We are supposed to subtract the given values. So we have 10 meters, 9 decimeters, 31 centimeters, and 2 millimeters, minus 8 meters, 9 decimeters, 38 centimeters, and 9 millimeters. So we are going to start solving this from our right hand side. So here we see 2 minus 9 is not possible. So we are going to take 1 centimeter from 31 centimeters. And we know that 1 centimeter equals to 10 millimeters. So adding it here, we are going to have 12 millimeters. So solving the values at this column, we are having 3 millimeters. Okay, so for the next part, we have 30 centimeters minus 38 centimeters, which is also not possible. So we are going to take 1 decimeter and adding it here. Okay, so now here we have 40 centimeters minus 38 centimeters, of which the answer here becomes 2 centimeters. Okay, so our next part here we remain with 8 decimeters minus 9 decimeters, which is not possible. So we are going to take 1 meter from here, then adding them, we are having 18 decimeters, of which we minus 9 decimeters, and the answer becomes 9 decimeters. And our last part, we have 9 meters, then minus 8 meters, the answer becomes 1 meter. Part B of the question, find the simple interest on shillings 10 million invested for 5 years at the rate of 6% per annum. Okay, so this is the simple interest problem. Okay, so let us consider the following formula for the simple interest, which says I equals to PRT over 100, of which I is a simple interest, P is the amount invested, of which you've been given as 10 million, R is a simple interest rate, which you've been given as 6%, T is a time of investment, of which we have been given as 5 years. Okay, so now we are going to substitute these values into our formula. Then our equation is going to be I equals to 10 million times 6 times 5 over 100. After solving the values, we are having I equals to 3 million shillings. And this is the amount required. Question number 4, part A. Calculate the size of angle X and Y in the following figure. So we have been given the figure there. This is the geometry problem. From the figure, we can see that angle X and this angle forms alternate interior angles. So we can conclude that angle X equals to 40 degrees. And also from the figure, we can see that angle X and Y are located in the straight line. So we can conclude that X plus Y equals to 180 degrees. Okay, so now let us substitute the value of X in order to find the value of angle Y. So our equation is going to be 40 plus y equals to 180 degrees. Let us now rearrange this equation. We are going to have y equals to 180 minus 40, of which after solving the values, we are having 140 degrees. And those are the values of x and y requested. Part B of the question, find the perimeter of a right-angled triangle whose base is 4 minus under root 2 centimeters and height is 4 plus under root 2 centimeters. Okay, so let us consider the following sketch. So we have triangle A, B, C. So here is 4 plus under root 2 and here is 4 minus under root 2. Okay, so next, in order to find the perimeter, we first find the length AC. So here we are going to use Pythagoras theorem, which says AC squared equals to AB squared plus BC squared. Okay, so now let us substitute the values which have been given. AC squared equals to, in brackets, 4 plus under root 2 squared plus, in brackets, 4 minus under root 2 squared. Okay, so next let us expand our equation. We are having, in brackets, 4 plus under root 2, in brackets, 4 plus under root 2 plus, in brackets, 4 minus under root 2, in brackets, 4 minus under root 2. Okay, so next we are going to expand the expression. We are having 16 plus 4 under root 2 plus 4 under root 2 plus 2 plus 16 minus 4 under root 2 minus 4 under root 2 plus 2, of which after solving the values, AC squared equals to 36. Okay, so now let us apply the root both sides. Then our equation is going to be under root AC squared equals to under root 36. Solving this, we are going to have AC equals to 6 centimeters. Okay, so now to find the perimeter, we are going to take 6 plus, in brackets, 4 minus under root 2 plus, in brackets, 4 plus under root 2, of which after solving the values, we are having perimeter equals to 14 centimeters. And that is going to be our answer. Question number 5, part A. Solve the equation. So we've been given two equations there. So here we have 2x plus y equals to 20. Let us call this as equation number 1. And then we have x equals to 35 minus y. We are going to call this as equation number 2. Okay, so next, let us substitute equation number 2 into equation number 1. Then we are going to have 2 in brackets 35 minus y plus y equals to 20. Okay, so next, let us open the brackets. We are going to multiply each number inside the brackets by 2. then our equation is going to be 70 minus 2y plus y equals to 20. Let us now rearrange this equation. We are having negative 2y plus y equals to 20 minus 70. Solving this, we are having negative y equals to negative 50. Then next we are going to divide by negative 1 both sides in order to eliminate the negative sign. Then our equation is going to be y equals to 50. Okay, so now let us substitute the value of y into equation number 2. Then our equation is going to be x equals to 35 minus 50. Of which after solving the values, we are having negative 15. And those are the values of x and y requested. Part B of the question, solve the following equation. So we've been given that equation. Okay, so for this one, first we are going to expand our right hand side. So our equation is going to be 4 in brackets p minus p squared plus 1 minus p equals to 3. Okay, so now let us collect the like terms inside the brackets. Then our equation is going to be 4 in brackets p minus p minus p squared plus 1 equals to 3. Okay, so next let us simplify this. Our equation is going to be 4 in brackets 1 minus p squared equals to 3. Okay, so now we are going to divide by 4 both sides. Then our equation is going to be 1 minus p squared equals to 3 over 4. Okay, so next we are going to rearrange the equation to collect the constant terms. Then our equation is going to be p squared equals to 1 minus 3 over 4, of which this becomes p squared equals to 1 over 4. Okay, so next let us apply the root both sides. Then we are having under root p squared equals to under root 1 over 4. Solving this, we are having p equals to 1 over 2. And this is going to be our answer. Question number 6, part A. If the slope of a straight line through the points 7, 4 and negative 2, k is 1, find the value of k. Okay, so this is the coordinate geometry problem. Let us now recall the slope formula, which says slope equals to y2 minus y1 over x2 minus x1. We have several given values from our question. So we have slope equals to 1, x1 and y1, we can take this one 7, 4, and x2, y2, we can take this as negative 2, k. Okay, so now let us substitute these values into our formula. Then our equation is going to be 1 equals to k minus 4 over negative 2 minus 7, of which this becomes 1 equals to k minus 4 over negative 9. Okay, so now let us multiply both sides by negative 9. Then our equation is going to be negative 9 equals to k minus 4. So next we are going to correct the constant terms. then our equation is going to be k equals to -9 plus 4, of which this becomes -5, and this is the value of k requested. For part B, by using a sketch, find the image of the point A 5,2 under a reflection in the line y equals to 0, followed by another reflection in the line y equals to x. Okay, so this is the transformation problem. We have to remember that for the reflection, image is located the same distance from the line of reflection as the original point, but opposite side of a line of reflection. And also, the line joining the original point and an image is perpendicular to the line of reflection. Okay, so now we are going to draw the x and y axis, and then we are going to label them. Remember, line y equals to 0 in x-axis, so we are going to locate point A with 5,2. And then next, we are going to draw a perpendicular line from point A crossing line y equals to 0. Next, we are going to measure the distance from point A to line y equals to 0. Now, using the measured distance, we are going to locate the image of point A. Therefore, our A image is at 5, -2. Okay, so next we are going to draw the line y equals to x. Then we draw a perpendicular line from point A image crossing line y equals to x. Then we measure the distance from the point A image to line y equals to x. Now, using the measured distance, we locate the image of point A image. Therefore, an image of point A image is -2, 5. Question number 7, part A. Use laws of exponents to simplify the following expression. So we've been given the expression there. Okay, so for this one, first we are going to introduce given exponents for each term in a brackets for both numerator and denominator. Then we are having 2 squared times r power 3 times 2 over 2 power 3 times r power 3. Let us now simplify further our expression. We are having 4 times r power 6 over 8 times r power 3. Okay, so next we are going to apply the law of exponents for division to combine the variables. Then our expression is going to be 4 times r power 6 minus 3 over 8. Simplifying this further, our expression is going to be r power 3 over 2. And this is going to be our answer. Part B of the question, if log 2 equals to 0.3010, log 3 equals to 0.4771, and log 7 equals to 0.8451, find log 42. Okay, so for this one, first we are going to express 42 as a product of the prime factors. Then we can write this as log 42 equals to log 2 times 3 times 7. Okay, so next we are going to apply the product rule of logarithm. Then our expression is going to be log 2 plus log 3 plus log 7. Okay, so next we are going to substitute the given values of these logarithms from our question. Then we are having 0.3010 plus 0.4771 plus 0.8451, of which after solving the values we are having 1.6232, and this is going to be our answer. Question number 8, part A. Rectangle ABCD is similar to rectangle WXYZ. If BC equals to 9 centimeters, AB equals to 4 centimeters, and WX equals to 5 centimeters, calculate the length XY. Okay, so for this one, we have to remember that for similar figures, the ratio of the corresponding sides must be constant. We can express that as AB over WX must be equal to BC over XY. Okay, so from our figures, AB is 4, WX is 5, BC is 9. Okay, so now let us substitute these values into our equation. We are having 4 over 5 equals to 9 over XY. So next we are going to cross multiply these values. Our equation is going to be XY 4 equals to 5 times Y. Let us now divide by 4 both sides. Then our equation is going to be XY equals to 5 times 9 over 4. Solving this, we are having XY equals to 11.25 centimeters. And this is going to be our answer. Part B of the question, the figure below shows that AC equals to BD. Prove that ACB equals to ADB. Okay, so this is the congruent problem. From the question, we've been told that side AC equals to BD. And we can see that AB is common side for both triangle ABCD and BAD. And also we can see that angle ABD equals to angle BAD because they both have 90 degrees. Okay, so then we can conclude that from the fact that triangle ABC is congruent to triangle BAD, then ACB equals to ADB by definition of congruent figures. Question number 9, part A. A ladder on the ground leans against a vertical wall whose height is 5 meters. The ground distance between the ladder and the wall is 12 meters. For Roman 1, draw a diagram to represent this information. Okay, so for this one, we are going to sketch our diagram based on the given information. So first we are going to draw a vertical wall, and then we are going to draw the ground, and then we are going to draw a ladder connecting the wall and the ground. So here the wall is 5 meters and here the ground is 12 meters. And this is going to be our sketch. For Roman 2, using the diagram in part 1 above, find the length of the ladder. Okay, so for this one, we are going to use the Pythagoras theorem to find the length. The theorem says c squared equals to a squared plus b squared. Okay, now from our diagram, a is 5, b is 12, and c is a ladder. Okay, so now let us substitute these values. Then our equation is going to be L squared, representing the length of a ladder, equals to 5 squared plus 12 squared. Solving these values, we are having L squared equals to 169. Okay, so next we are going to apply the root both sides. Then our equation is going to be under root L squared equals to under root 169. Solving this, we are having L equals to 13 meters, and this is going to be the length required. Part B of the question, given that where sin A equals to 3 over 5 is an acute angle, find without using mathematical tables the values of for Roman 1 cos A. Okay, so this is the trigonometric ratio problem. We are going to consider the following relation, which says sin square A plus cos square A equals to 1. Okay, so we've been given the value of sin A in our question. Then let us substitute this value. Our equation is going to be, in brackets, 3 over 5 squared plus cos square A equals to 1. Solving this, we are having 9 over 25 plus cos squared A equals to 1. Okay, so now let us rearrange this equation. We are having cos squared A equals to 1 minus 9 over 25. Solving our right hand side, our equation is going to be cos squared A equals to 16 over 25. Okay, so now let us apply the root both sides. Then our equation is going to be cos A equals to under root 16 over 25. Solving this, we are having cos A equals to 4 over 5. And this is going to be our answer. For Roman 2, we are supposed to find tan A. Okay, so for this one, we are going to consider the relation of tangent, which says tan A equals to sin A over cos A. Okay, so now let us substitute the values for sine and cosine. Then our equation is going to be tan A equals to 3 over 5 over 4 over 5. Okay, so now let us rearrange this expression. We are having tan A equals to 3 over 5 times 5 over 4. Simplifying this, we are having tan A equals to 3 over 4. And this is going to be our answer. For Roman 3, we are supposed to find 1 minus sin A over 1 minus cos A. Okay, so since we already have the values for sine and cosine, so let us substitute them. Our equation is going to be 1 minus 3 over 5 over 1 minus 4 over 5. Of which, solving this, we are having 2 over 5 over 1 over 5. Rearranging this, we are having 2 over 5 times 5 over 1, of which after solving the values, we are getting 2. And this is going to be our answer. Question number 10, part A. In a class of 32 students, 18 play golf, 16 play piano, and 7 play both golf and piano. Use a formula to find the number of students who play neither golf nor piano. Okay, so this is the set problem. Let us consider the following formula, which says number of A union B equals to number of A plus number of B minus number of A intersection of B. Okay, so from the given information, we are going to say those play golf are represented by number of A, which equals to 18, and those who play piano are represented by number of B, which equals to 16. And number of A intersection B is 7. Number of A union B are those who play either of the two games. Okay, so now let us substitute those values. Number of A union B is going to be 18 plus 16 minus 7. Solving this, we are having 27. Okay, so now to find the number of students who play neither golf nor piano, we are going to take number of universal set minus those who play either of the two. So here we are going to take 32 minus 27, of which solving this we are having 5. Therefore, 5 students play neither golf nor piano. Part B of the question, a survey was done among students in a certain school in order to find the most popular subject. In this survey, each student voted once and the results were as follows. So we've been given the table there with the results. We are supposed to show this information in a pie chart. Okay, so to represent this information in a pie chart, first we are going to convert them into degree using the following relationship, which says degree for a given subject equals to data given over total number of data times 360. Okay, now from the table, the total number of data is going to be 50 plus 80 plus 120 plus 40 plus 80 plus 30, of which summing this we are having 400. Now to find the degree for mathematics, we are going to take 50 over 400 times 360, of which after solving the values we are having 45 degrees. Okay, so for English we are going to take 80 over 400 times 360, of which this becomes 72 degrees. For biology, we are going to take 120 over 400 times 360. Solving this, we are getting 108 degrees. For history, we are going to take 40 over 400 times 360. Solving this becomes 36 degrees. For geography, we are going to take 80 over 400 times 360, of which this becomes 72 degrees. And finally, for physics, we are going to take 30 over 400 times 360, of which after solving this, we are getting 27 degrees. Okay, so now we have all the degrees for the subjects. We are going to draw the cycle and we are going to make the partition according to the degrees we have. And our final pie chart will be like this.